Hi guys, welcome to my channel. I am Bearded Dev. Today in this SQL tutorial we're going to be looking at scalar functions. So what we're going to cover, we're going to look at how to create scalar functions, and the scenarios we're going to go through are we're going to bring back customer full names, and we're going to create a function that calculates customer spend as well. So scalar functions, what are they? They're a type of user-defined functions within SQL Server. So obviously we do have built-in functions as well. They can be like aggregate functions and some of the system functions as well. Scalar functions, they only return one value. So we use them within selects and where clauses, possibly group bys as well, but never in the from clause. For that we'd have to use table valued functions, and we're going to be covering those in a different video. And they also must be addressed by the two-part name, so we must always give the schema name and the function name as well. Let's jump over to SQL Server Management Studio and go through some examples. In this demonstration, guys, of course we're going to be using our database, the bookshop. And I'm just going to show you on the left hand side in Object Explorer, if I expand the bookshop and expand programmability, we can see we've got functions here. So if I expand that, I've got table valued functions, scalar valued functions, aggregate functions and system functions as well. So we're going to be looking at scalar valued functions today. So if I had any in the system at the moment, if I clicked on the plus sign, that would open and give me my list of scalar valued functions. Okay, so let's go on to a simple example of what we could use a function for. So let's say we just want to multiply two numbers together. We can do that easily within a select statement, but for the purpose of this we'll just do that within a function. So as we are creating a new object, we want to start off with the keyword create and indicate what type of object it is, in this case a function. We're just going to call this multiply for now. Now, one of the major advantages of using functions is we can pass parameters into them. So unlike views, which is just simply save select statements, with functions we have the advantage of being able to pass data into them in the form of parameters. So in this case I'm just going to declare two simple parameters. Notice how I've opened the brackets to start listing these parameters as well. So I'm just going to call my parameters just for ease at the moment at n and at m. They're both going to be integers, so we list our parameters under the create function statement after the name within brackets. And then what we want to do is tell SQL Server what we want this function to actually return, the data type that we want it to return. So the keyword here is returns, and because we're working with integers, we're just going to return an integer. And then we're going to start working on our function. So we've got the keyword as, and then we're going to put this within a begin and end block as well, the key detail of our function. What we're also going to do is declare a variable, and that variable is going to be what we pass our result into. So I'm going to declare at result, which is also going to be an integer, and later on we're going to return that variable from the function. And simply what we're going to do is just write a simple function which is going to set the, in this case we're going to use select at result equals at n multiplied by at m. So our variable is an integer, and then we're going to multiply the two parameters we're passing into this function together to pass into that variable, and then what we're going to do is return that variable. So we're going to return, if I can spell correctly, at result, and then we're going to close our end block. So that's a very simple function where we're going to multiply two numbers together. Let's go ahead and execute that now to see if it creates correctly. That's created correctly. If I just go over here and refresh the functions and open up scalar valued functions, we can see our name here, and we can open it to see the parameters that we actually pass in. You could also assign default values to these parameters if you wished. Okay, now let's go ahead and run a select from that function. So remember, we need to address this function by two-part name. What I'll do shortly is I'll take out the schema name and we'll see what happens. So let's pass two numbers into here that we want to multiply together. Let's say 2 and 9. 2 and 9. So we're just going to do a select. We don't need to use the from clause in this case, we're not looking at any tables, but we'll be moving on to some other examples later on. So if I just highlight that and execute that now, we've got the result as 18, and we'll just give that result a name, result. So as we can see, that function, we just pass in two numbers, that does all the work for us. Highly beneficial if there's a lot of, I don't know, some data that you need to work together, and you don't want to have to keep writing out the query again. So similar to a view, you don't want to have to keep writing out these extensive queries. The purpose of functions is to enable you to have reusable code that you can execute over and over again. Now let's take out that schema name and just run it with the select multiply again. So we'll get an error there to say it doesn't recognise that function name. So as we can see, as mentioned in the intro, we do need to address the function by the two-part name. Now don't worry, we are going to be moving on to some other examples, and again, because we're working with an object, we can just simply, I want to get rid of this function. It's not something I'm going to use. We will be moving on to examples of actual usable content. So we're just going to indicate the drop of the function, and we can see that's gone successfully. If I refresh the functions option, and we can see we've got nothing in Scalar functions at all. Okay, so let's open up a new query window and let's move on to a more usable example that we might come across when we're actually working with SQL in the real world. So we're just going to run a query against our customers table at the moment. So in here we've got the first name, we've got the middle name, which is nullable. Not everybody has a middle name, or we might not know that information. And we've got the last name. Now quite often than not, we want to always put these names together. So what we want to do now is, in our first scenario, we're going to create a function that returns the customer's full name concatenated. So what I'm going to do first of all is I'm going to check if the function we're going to create already exists. So we're going to be creating a function. I'm going to just abbreviate that with the name, start that with the name fn, just to indicate it's a function in our objects, and the type is fn. When we do videos on the other types of user-defined functions, you'll see that that actually changes. So you can have table-valued functions and inline table-valued functions as well. So we're going to say if the object ID is not null, effectively if it already has an object ID and exists as an object, we're going to drop that function. Okay, and then we're going to just put the keyword go just to indicate to keep going, and then we're going to write create function, and in this case our name is going to be fn full name. The parameters we're going to want to pass, we're only going to be working with one parameter, and that's just going to be our customer ID, which is going to be an integer. And it's going to return a VARCHAR because it's going to concatenate all of the names, and we'll just set that as a 150. Again, the keyword as will open our begin block, and we're going to declare a variable for this to return. So we're going to declare the variable full name, and we're going to set that as a VARCHAR 150 as well. That should give us enough room to concatenate the names. So what we're going to do is we're going to set at full name equals select the first name. Now remember, with the middle name we can have nulls, So if it is null, we're just going to simply replace it with blank. If we were doing this to generate some kind of material that we were sending out to these customers, we wouldn't want to address their their middle name as null. And then we're going to just put spaces in between those. If you haven't watched the video I've got on my channel on concatenation, guys, do go and check that out. That would make what we're doing here a lot of sense. So we're looking at from our customers table, and we're going to say where our customer ID, which is CID, equals at customer ID, the parameter that we are passing in. And then we're going to return our variable, which is at full name, and end. We better close those brackets there as well. So there we have our statement. We're looking to concatenate the first name, the middle name, and the last name. If the middle name is null, it's going to be replaced by blank. We're going to get that from our customers table, where our C_ID equals at customer ID that we're going to be passing in as our parameter. And then it's going to return that full name. So if I execute all of that now, remember we've got the check at the top to see if it already exists. That's been created successfully. So then if I select, what should we select? We'll select FN full name in this case, and we're going to pass in customer ID from our customers table. So it's going to pick up our customer ID and run this function for each customer. So if I go ahead, we haven't given it the two-part name, almost caught myself out there. And if we go ahead and execute that now, we can see we've got a problem. We're only returning the first name and possibly the middle name if we have one. So let's go back and have a look at this function. So we've got here the first name plus the middle name plus the last name. Now let's just run our select again from that table. So our column names are correct. And we can see what we've done here is a common error. We forgot to put in the additional plus. So we're going to change it from the create function to an alter statement. So because we're working with an object, we have our three keywords: create, alter, and drop. And we're going to add that plus in. What I could have done is left this as a create, because we have got the check there to see if it already exists. So I'll go ahead and run that alter function. That's completed successfully. If I go ahead and run that now, we can see I'll just alias this as full name, so we don't get the result as no column name. And if I execute that now, we've got our result. But as we can see, where we've got customers who have got middle names, that's worked out perfectly fine. The problem we've got is if we have a look at Michael Smith, our top result, he's got his first name and then he's got two spaces, and then he's got his last name in this case. So because we're replacing the middle name with a blank, we're ending up with our customers that don't have a middle name have actually got two spaces. So what we're going to do is go back to our function, and we're going to drop a replace, which is a built-in function. We're going to replace any blank, any double spaces with just a single space. I will be doing another video as well, guys, on the channel on character functions, so we will have a look at that in another video. But replace would just allow you to search for anything, so you could say replace the letter T with the letter S. I don't know why you'd want to do that, but that just gives you a general idea of what the replace actually does. In this case, we're going to change it back to a create function, and we're going to run our check at the top as well. So our object ID, we will have an object ID for our full name function, so it should drop that function and then recreate it. That's completed successfully. If I execute this select now, we can see we've got rid of those double spaces within our query, which is exactly what we wanted. Now we're going to be moving on to our second and last example in this video, where we want to calculate the total spend per customer. So I'm just going to open up a new query window, and we're going to be creating a new function called total spend. So again, we'll do our preliminary check to see if fn total spend already exists. Again, the type is fn, and it's always good to start your object names with the type that they are. So if you're creating a view, start it with VW. If you're creating a stored procedure, start it with SP or P. If you're creating a function, start it with FN. It just makes you it's then easier to differentiate between the types of objects that you've got within the database. It's not something that's required, but it's just general practice, and it's something that's pretty easy to pick up. So if this function already exists, we're going to drop it, and then we're going to create it again. I don't believe it does exist. In fact, we checked earlier in the video and it doesn't exist. And in this case, we're going to be passing in, again, we're just going to be working with one parameter, which is just going to be the customer ID. So the purpose of this function is we want to be able to pass in a customer ID, and it's going to return to us the amount that that customer has spent. So in this case, we're going to be returning a decimal, so a numeric value, and that's going to be, as we're going to be looking at. So we're going to be looking at another variable, which we're going to call total spend. In this case, we're going to set that as a decimal, 16.2. It's pretty standard. We haven't got customers that have spent sort of that much money with us that we'd need to have that many digits, but it's not to worry about for the time being. We're not too concerned about the data type storage, as we're only working with small amounts of data at the moment. So what we're going to want to do, first of all, we want to look at our customers table, and then we're going to be joining to our orders table, and we're going to be joining on our customer ID equals, and then we've got O_customer ID in there, and orders table stores the total amount the customers have actually spent. So if I just run this query to give you an indication of that, we can see we've got the column order total. So I just wanted to go through this as an example, because you can have joins. It's just a standard statement, a normal statement you would have within a function. So what we're going to want to be returning is a sum of O total, and we want to actually group. I'll just drop this onto a second line to make it more readable, and I'll put a space there as well. We're going to be grouping by our customer ID. Okay, so that would be our standard select, but obviously in this case we want to pass that into our variable, so it's going to be to select at total spend equals the sum from the customers joined to the orders, the sum of the total, and we're going to be grouping by our customer ID. And we're also going to need to pass in a where clause as well, to say where our CID equals the parameter that we actually pass in to get this function to make some kind of sense to us. Then what we're going to be doing is returning our variable at total spend, which is a decimal data type, if I could spell the word return correctly, and then we'll just drop an end on there to close that begin and end block. So if I execute that now, we've got our command has completed successfully, and let's have a look at that. So what I want to do is select first name, customer first name, and customer last name. We're not going to bother with middle name in this case. And then I want to call the function. So I want to call dbo.FN total spend. It's coming up with full name that we created earlier. I haven't refreshed IntelliSense yet, so it doesn't actually recognise it as of yet. We're going to pass in customer ID, and that's going to be from our customers table. So if we have a look at that now, again I forgot to alias that. And there we have our total spend per customer. We can see some customers we've got in the database haven't put any orders through yet or haven't bought any books from us. So we're going to also use this function within the where clause. So we're going to say where our function, and passing our customer ID is greater than 0. So we want to actually see customers that have spent some money with us as well. And then we can add an order by clause to the end of our query. Remember, we've aliased the function here as total spend within the select statement. Order by clause is evaluated after the select statement, so we don't need to look at that function within our order by clause, and I'll just drop a descending on there as well. So we've got Michael Smith, who spent £100, Paul Thompson, who spent £61, Sandra Lewis, who spent £15. As you can see, our customers don't like to spend very much with us, but that's only just because I've got a small amount of data in here at the moment. It will be increasing over time. I didn't want to go through examples just using the standard Microsoft databases like everybody else does. I wanted to actually come across some real world scenarios. So I really hope you have enjoyed that video, guys, on scalar functions. Check out my other videos on the channel if you're interested in SQL tutorials, business intelligence, reporting. There is a lot more content coming soon. So do subscribe to the channel and hit that notification button to be kept informed when new videos are uploaded. Thanks a lot for watching.